Hello students, this is the second lesson on growth and decay. Today we're going to be looking at how to work through problems backwards. So sometimes questions will give you a final answer, a final result, and your task will be to work out what the rate was or how many years it's taken, for example. So here is an example, as I was describing, of one where you need to work out the value of R. So reading the question, Bill invests £500, so they've told me the amount, I'm just going to write that here, amount, on the 1st of January 2004 at a compound interest rate of R. So that is the bit, if I just put a question mark, that I don't know, okay? The value of the investment after n years, so again they haven't told me how many years, I'll just put a little question mark there as well, is given by the formula V equals 500 times 1.045 to the power of n. Work out what the rate is. So if we think back to last lesson, I showed you the following formula. I said amount times multiplier to the power of n gives you your final value. Now here they've done that. They've said amount times something to the power of n. This bit here is the multiplier, and I need to work out what the rate is. So what I'll remind you is that it's 100% plus something, okay, and then I divide it by 100, and that ends up giving me my multiplier. So what you need to think about really is, what is the rate going to have been? So 100% plus something divided by 100 ended up giving me 1.045. The answer, as some of you will have spotted, is 4.5%. Okay, so the rate is 4.5%. So here are two more examples. I'm going to take you through them both. First one says John invests £6,000 in an account offering a rate of X% compound interest for 2 years. At the end of the 2 years he has £6,303.75. Work out the value of X. So again, what I want to do is return to the formula, which you should now know off by heart, I hope. Amount times multiplier to the power of n equals well, I suppose I can write final amount. So I'm going to fill in the bits I know. Starting amount, years, final amount. Okay, so 6,000 times, the multiplier is the bit I don't know, so what I'm going to do is I'm just going to write x to the power of 2 equals 6303.75. Now it's a case of solving this equation. What I want to work out is what is x. So the first thing I'm going to do to both sides is divide by 6,000. So I'm going to divide both sides by 6,000. That will give me x squared equals, I've got to divide this number here by 6,000, so 6303.75 divided by 6,000 gives me an answer of 1.050625. Now what you need to think about is, what's the opposite of squaring something? The opposite of squaring something is square rooting it. So I'm now going to square root to work out what that multiplier must have been. So square root the answer, and that gives me 1.025. Now we're very nearly at an answer now. If the multiplier was that, and remember the previous question, I'll just remind you, the previous question we worked out that the rate, when it was a multiplier of 1.045, the rate was 4.5%, because remember it's 100% plus something. Okay, so look at this question then. What is the rate going to have been here? 100% plus something, and the something here is 2.5%. Okay, So x must have been 2.5%. There's my final answer there. Okay. The only thing I suppose I should, I'll just put an arrow here. I know I've written x is 1.025, but that x is the multiplier. This x here is the actual rate, which is what they're asking for. They want the percentage, which is 2.5%. Now the last question, as the example, Jasper invested £2,400 for n years in a savings account. He was paid 7.5% compound interest. At the end of n years, he had that much in the account. Work out n. So, let's just move the other one out of the way so people aren't getting confused by that. So, what I've got here then, students, is I've got a question where I know the starting amount. I'm just writing the formula again. Amount times multiplier to the power of n. And I'm going to write equals final amount. So I've got the final amount. I don't know n. I can work out the multiplier. And I also know the starting amount. So I'm going to plug in the 3 bits that I do know. 2,400 is my starting amount. If I'm getting a 7.5% interest rate, then let's do 100% plus 7.5% and divide it by 100, which will give you 1.075. So that's my multiplier, 1.075. And the power is the bit that I don't know. Equals 3445.51. So what I would now do, students, is I would divide both sides by 2,400. Although in fact there is a so what I would now do, students, is actually trial and error. Okay, so I'm going to trial different numbers until I get this answer that I'm seeking. Okay, so if I put in my calculator 2,400 times 1.075 to the power of, let's just try 3 years as a starting point. In fact, let's start with 2 years. So I'll start with 2 years. So if I put squared in there, that gave me an answer of 2,773. £2,773.50. So I'll just write down 2 years. That gave me 2,773.50. So let's try 3 years now. So all we have to do is go back into the calculator, change that for a 3, and do it again. This time I get 2981. So 2981.51. And that still isn't the number I'm seeking. I'm looking for 3445, so I'll go back in. Let's try 4 years. I'm getting closer now, so 4 years. That takes me to 3205, and if I round it to the nearest penny, that 5 rounds a 2 up, so it's 13 pence. Still not there, but I'm guessing it's going to be 5 years. Let's have a look then. Put 5 in there, and that looks like the one. 3445.51. So the answer to this question is what? Think for a moment. They've asked me to work out n. How many years did it take? Now I've just trialed a few. I did 4 different trials. 2 years, too low. 3 years, still too low. 4 years, still too low. 5 years, that's the one. So the answer then, n, is 5 years. Okay. So here are 3 questions for you to try. What I'd like you to do, please, is to attempt all 3 questions. Take a picture of your solutions and upload this to ClassCharts to complete today's remote learning. Good luck.